So this video relates to the Excel modelling task that we looked at, and in this video I'm going to talk you through the example spreadsheet that you can find online on my website and on Blackboard. And there's a series of different things that we looked at through this task, but you'll notice that when you open the sheet it says that there are circular references. That's okay, that's something we're expecting. So if we click OK to that, we don't need to read the help file, and I'll show you where you can change the settings for that. So in the main office menu, you want to go to Excel options, and then in the formulas tab you want to, on the tick box, enable iterative calculation. You also want to make sure this maximum iterations is set to the number 1. And click OK. Now, for this first sheet, that doesn't actually matter. There are no circular references on this. The first sheet, entitled Cube, is just to look at some of the built-in functions of Excel. So, if I click in cell B2, you can see at the moment that's showing the value 1. And cell B3, the B dimension, is also the same value, and you can see in the formula bar it's equal to the A value, and you can see all 3 dimensions are equal to each other. So if I change the top number and make it large, they all change. Of course, you know that to calculate the volume of a cube, you times dimension A by B by C. Well, if we want to use some built-in features of Excel, we can start looking at varying a value in an automated way. So if I go onto my data tab, there's a button called What If Analysis. If I click on the arrows there, there's 2 we're going to look at: Scenario Manager and Goal Seek. So for Scenario Manager, I'll load that, and there's 10 scenarios I've already preloaded in here. And what they're going to do, I'll add another one just so I can show you. I'm going to call it Scenario 11. It says, which cell do I want to change? Well, I want to change cell B2. Okay. And I'm going to change that value to the value 11. I'm going to click OK. So you can now see I've got 11 scenarios in my table. If I double click on one of these, you can see that the values in my spreadsheet have changed. So the cell B2 has become worth 4. Click on the 6 and they will become worth 6, and that's showing 6 cubed. I can also do a summary of all of my scenarios together. So the only value I'm really interested in is the volume at the end. So if I click OK here, it will run all the different scenarios I've preloaded. So it will set the value in cell B2 to 1, then to 2, then to 3, all the way through to 11, and it will show me the value in B5 for each. If I want to pick more than one cell, I can hold Control on the keyboard and I can click different cells, and it will show me both of those. Click OK. It'll take a moment, but it will run all of those different scenarios. You can see this is the value. This current column here is where I started it at, and then you can see it's reported all of the different scenario values we preloaded. And you can see in the volume row, we've got 6 cubed is 216, 7 cubed is 343, etc. So that's one feature of Excel. This scenario manager, you can change one cell and find what impact it has on other cells in your spreadsheet. If I go back to cube though, it hasn't actually overwritten anything, it's still there as the original 6 that it was before we started. The other example is the Goal Seek example. So if I go and click on Goal Seek, so still on What If Analysis, but Goal Seek, I want to set, and this time I'm interested in working the other way, so I want to aim for a volume of, so change cell B5, I'm going to aim for a value of 1728. The only cell I want to change is cell B2. So what this will do is it will work through all the different permutations, changing cell B2 until cell B5 reaches a value of 1728. You can see that 12 cubed is 1728. It doesn't have to be a whole number, I just picked whole numbers because they were slightly easier, but we can set the volume to 50,203 just by changing one dimension of the cube. So 36.8901 cubed is 50,203. So that's just a couple of the built-in features of Excel. The other three sheets that were provided all work on this same counter. So if I click on the circular motion sheet, we've got the key bit is looking at this counter here, A3 down to A6, to B6, and this separate cell underneath the D. So I'm just going to unlock this sheet. So what we've got here is a series of numbers that we can predefine. So when we turned our iterative calculations on at the beginning, we set our maximum iterations to 1. So that's how many the size of step we're going to take. Now I set it to 1 here so that I can change it here. How we step upwards each time, set the increment we go up in each time. So what I'm going to do is this counter is simply going to count from 0 to 360 in steps of 1. But the magic all happens in this cell B5. So what we want to look at is what's happening in this formula bar. So the first if says if D3 is blank, which it currently is, show B3. And B3 is our starting value that we've predefined. So if D3 is blank, it goes back to the beginning. If it's not blank, then we look at the next bit. So if B5 is the value we're currently, the cell we're currently clicked in. So this is where our circular reference comes in. If B5 is less than B4, so less than the finish value, then I want it to show B5 plus the increment, one more step. So whatever was in there before, plus a step. Otherwise, I want it to show the end value. So I never want it to exceed the end value. So if I put a character in here, any character will do, then we can see it's stepped up to 1. Every time I want the sheet to recalculate, I push F9 on the keyboard, and you can see it continually counts upwards. Now what we can do with that is we can start to do calculations using this stepping feature. So the simple example you can watch on the graph, as I keep recalculating, it will continue to trace out a circle with a radius of 1. As soon as I get to 360, I'm still holding down F9, but there's nothing happening, it won't exceed 360. Now the way that's working is I've got a formula in for the x coordinate. I'm looking at taking the step value that we're calculating, converting it to radians, so saying convert to radians cell B5, and then I'm finding the sine of it. And similarly, for the y coordinate, I'm finding the cosine of it instead though. And then when I want to plot it on my graph, plot the two coordinates, but I plot it as one data point with an x value and a y value from B8 and B9. Now if you just choose to plot that, so if you were to just highlight these and ask it to plot, it won't plot it correctly. It'll do something like that. So you right click on your graph, you select data, you edit the series, and you tell it I only want one value to be an x value. Delete all that, and you say I only want one value to be the y value. And that would be doing exactly the same thing, apart from this one doesn't have fixed axes. So I can right click on an axis, format it, and fix my values between -1 and +1. Oops. Maybe a little more. And that's now fixed to the y-axis, and I can do the same with the x-axis. So now, if I reset, I delete my character, the counter resets, put a character in there, still doesn't matter which, and you can see it's working exactly the same way my original graph was. So that explains the circular motion part of the sheet. I've also got two other parts. I've got one called projectiles. So this relies on some dynamics and some dynamics knowledge. So in order to be fair, because you may not have studied the dynamics part of the course yet, all the knowledge you need for that is provided in the crib sheet that I provide with the task. Okay, but what we've done again, these first few cells that are now highlighted are exactly the same as before. The only difference is I've chosen a different endpoint and I've chosen a different step size to go up in. What I'm doing is I'm looking at an instance where I'm launching a projectile at 30 degrees from the horizontal, and it's launching at a velocity of 25 meters per second. So if we draw that, if I can. So something like that. So what I'm going to be doing here is I'm going to have to work in two components. I'm going to have to look at an x component and a y component. So my x velocity is always going to be converting the angle to radians, the cosine of it multiplied by the initial velocity. So that's going to be a constant x velocity. For the y component, it's not quite so simple. So for the y component, we work out the initial velocity by doing the same calculation as for the x, but we're doing the sine of it. But the y component is going to be affected by gravity. So that's only going to be the initial y velocity. We're then going to use our Suvat equations. So again, if you haven't studied this, don't panic. This is more the dynamics side of things than the Excel that I'm explaining at the moment. But what that's looking at is that's looking at our time step multiplied by our acceleration, so AT plus U. So V, which we're calculating, is U plus AT. Okay. Acceleration is constant. This is only for the upward part of the journey, so it's constantly minus 9.81. And our height that we've reached is going to be ut plus a half at squared. And then our maximum height is calculated by saying if B14, so the height we're at in a particular time step, is greater than B17, then I want it to show B14. Otherwise, I want it to show B17. And that's showing 0 currently because I've just recalculated it. But after I've run it once, that will work out the maximum height. What we need to do is build in a reset feature for this in case we ever change anything. So it's not quite perfect yet. So if we take the start of our step feature, we can add that in and close an extra bracket at the end, and that will make it work much better. So here we're saying if we reset, if the reset box is empty, show the start value of 0. Otherwise, if B14 is bigger than whatever's in B17, show that. Otherwise, show B17, so you're always showing the maximum height. Similarly, we've got here, we're looking at if B12, so if our velocity is bigger than 0 or equal to 0, then I want to show the time that we're at. Otherwise I want to show whatever was in B18. Okay. And then we work on the downward journey. So the initial downward velocity is 0. The upward velocity, the final velocity of the downward journey is our initial velocity 0 plus AT. However, my time is my total time B5 minus the time it took to get to the top, with the time just on the downward journey, and my position is UT plus half AT squared. However, we've also got, we're working from a different start, but working from the top now. That's why we've got the B17 referenced. If all of that sounds like gobbledygook, don't worry. Okay, you can just copy these formulas from the crib sheet. What's important is the next bit. So as I recalculate this, you can see the blue dot is doing exactly what it was doing before. However, there's now also a red dotted line that's appearing on the sheet as well. The key difference for this task is the red dotted line. A little bit of lag in the calculation there. And we can see it's hit the ground there. So we can see the curved trajectory that the projectile's taken. And the extra bit is done with these two columns V and W. So what V and W are doing, and the reason for that lag, is the whole of column V and the whole of column W are constantly rechecking, are they the right value? So we've got some calculations here for, in that time step we're in, it's working out our X position and our Y position. So our X position is our X velocity times time. Our Y position is going to be working out, are we going up or are we going down? And picking out the right Y position for a particular time step. Okay. But the key bit that we need to focus on is what V and W are doing. So what they're doing is they're saying, well, first of all, if I take out my X from cell D3, it will reset all the data that's stored. The next bit is saying if the row number is bigger than B4, so if the row that I'm clicked in at the moment is bigger than B4, divided by B6, it will show 0. So B4 divided by B6, the final time we're interested in, divided by the number of steps we're going to take, divided by the step size, so 100 divided by 0.05, that will give us the number of steps we're going to take, the number of data points we're going to collect. So if the row number we're in is bigger than the number of steps we're going to take, then it will just show a 0, because it will never be able to store data. We're not collecting that many data points. So for us, if I do 100 divided by 0.05, I get 2,000. So there are 2,000 data points. So row 2001 in the sheet will always say 0 for this endpoint and this increment. If B5, so if the step size is equal to the increment times the row number, ignore the -1 for a moment, so if our increment times our row number is equal to the step we're in, then this cell that I'm clicked in will store the X position. Otherwise, it will store whatever it was in the previous check. So it will constantly overwrite itself. So these are constantly copying and pasting the value that was there previously, unless it's in their step, in which case it records whatever's here. So when I hit reset, let's do that. Oops. So when I hit reset and I start calculating, you can see that the X position currently is 3.25, the Y position 1.2. If I hit calculate, don't know why it stored it twice, but it stores the X position and the Y position from the previous time step. So now we've got 4.33 and 1.76. If I hit calculate, it stores 4.33 and 1.76. The reason for the -1 in the equation, I want to go back to the 0 point. So I want to be able to plot through 0, 0. In order to be able to do that, I need a row 0. Clearly row 0 doesn't exist, so I put this -1 in there. So effectively this thinks it's row 0, this thinks it's row 1, this thinks it's row 2. Okay. The third problem with the leak, I'll leave you to look through on your own. Just need to get rid of these notes. I'll leave you to look through, because this works in a very similar way. There's nothing extra here, it's just a different application of the same ideas. So it's the idea of a tank filling up. We've got the question over on the right hand side. It's the idea of a tank filling up. You can change certain variables and you can say, is there a leak or not, yes or no, and you can watch how much water is in the tank at any point. So that concludes the built-in features of Excel and the short modelling exercise that we looked at, modelling some different scenarios in Excel.